So, correct, I'm from IBM, but I will not provide any details regarding portfolio for today. The topic I will talk about how to maintain our Kubernetes clusters in the GitOps way with ArgoCD. Means also I will not introduce ArgoCD. I will also not talk about how to provision a Kubernetes cluster. Maybe this is another talk. So, but all the subsequent steps like installing any operators like for logging, for Kafka, or external secrets operator and so on. So with objective to get a complete cluster so that we can roll out to the teams. I will present you an approach, how we make this in some of our projects that we have in the past. Again, some words about me. Hafid Haddouti, solution architect at IBM, mainly focus of cloud transformation, modernization topics, and so on. Means all the nice topics regarding creating platforms, GitOps, automation. In the talk today, I will go through some slides presenting the ideas, and then I have also some demos stuff to show a real life demo. Good, let's get started. For application deployments and their release management, we have already, I would say, a good maturity of concepts and tools. With Helm and Customize, we can define declaratively the target state, for example. With ArgoCD, we observe and reconcile any kind of changes in the Kubernetes cluster. And let's say if we do it right, we prevent also any kind of manual manipulations in the cluster. Usually, we have also some working version and release process to bring new changes to the environment. So overall, when it comes to deploy applications in a cluster, we can say we see a consistent usage of GitOps principles. But if we look at the entire platform stack, the application deployment is a very small part of the entire platform stack. It is an important one for sure, yes, but it's not the last one, not the only one. Especially if the remaining parts are not managed or maintained in an automated way. And usually, the applications need also additional features to work properly on a cluster, like middleware components, Kafka, or something like that, but even also CI/CD pipeline components, Tekton. And even for our operational activities, we need any kind of helpful components, like logging, backup, or restore mechanisms, or how to handle secrets in a cluster. So before we allow that our stakeholders accessing a new cluster, we have also set up, configure, and finalize the cluster before we roll out the cluster to the teams. So the question is how to set up and configure a fresh new Kubernetes cluster in a declarative and automated way, which is also repeatable. Because how many clusters do we have usually? One? Probably not. 10, 50, 100, something like that. So it's important to have a way that the configuration of the cluster is repeatable, and that the cluster configuration has also a lifecycle management. So let's see how we can do this with GitOps with ArgoCD. Maybe also some regarding the wording. I'm always try to use the word capability to distinguish this from the normal Kubernetes application deployment. But in general, the concept and the ideas are totally the same. So capability in the context of in this context is any kind of feature that we can install and configure in a Kubernetes cluster. It could be an operator for logging, for Kafka, or an external secrets operator. But it could also be any kind of custom implementation, custom configuration to adjust the behavior of the cluster itself, or to add some integration, like an AD integration. So, and the capability itself is defined in very pure, normal Kubernetes manifest files. In our case, we're using Customize. So each capability has an own lifecycle and also an own versioning mechanism. Important to note here is that the capabilities are usually cluster independent. So if we have any cluster specific configuration like secrets, certifications, for example, then we are using this normal customized overlay concept, creating a cluster specific configuration, set the reference to the base original capability, and then we have the cluster specific one. In the demo, I will also try to explain and show here an example. Regarding versioning, so the motivation here is that we have one single source of truth. defining the cluster configuration. And this includes any kind of components, capabilities that you want to specify and to install on a Kubernetes cluster, also with the related version. So let's name these sets, so the capabilities and also the corresponding related versions, a platform version. And on the right, you see an illustration for two platform versions highlighted with different capabilities. So in any case, we change a capability, updating a version or adding a new capability. This will result in a new platform version. So the idea, I would say, is straightforward, and the motivation is to get the reproducible configuration that defines how the cluster, the entire platform, let's say, should be configured. Let's have a closer look on how the version logic works. At the top, we see the details regarding the version. Each platform version is defined in an own version YAML file and has also a name like Aurora, Blade, something like that. The version YAML file consists of a list of capabilities with the corresponding version. And the capability version is usually a revision to a state in Git. So it also means that it's possible to have a different kind of revisions for each capability. To mention here is that the version, that the platform version, is totally decoupled from a cluster definition, from a real cluster instance. A cluster configuration is represented by an own configuration file named cluster YAML. The cluster YAML file references the version, the platform version, by using a platform version name, like Aurora, Blade, and so on. And the merge of both files defines the target state of the cluster. So the question is why we need a merge. The merge is, I would say, very helpful, especially in the case if we need another version of a capability which is defined in the referenced platform version. Let's consider, for example, we have in the meantime a new capability version during a security patch or something like that, but the latest platform version release is still not released, not public. In this case, we can use the merge to override any kind of capability information like the version. Regarding lifecycle, each highlighted area has its own lifecycle and version handling. So it means we can also work at the capabilities and produce new versions, which are without any affecting the platform version. To be more precise, each capability has its own lifecycle, release management, and versioning stuff, and so on. Introducing a new platform version means we enhance the previous platform version, adding some new capabilities, changing the platform, changing the capability version. And as soon we have a stable version, we can release it in the platform version, for example, creating a new Git. And then from then on, each cluster can use it by referencing the platform version name, and the revision. And this allows us to bound the cluster to a specific version, especially to a specific cluster version. To a specific platform version, sorry. Some words regarding the flow. We will not cover all steps today, but usually we provision the cluster, hopefully in an automated way. Then you bootstrap the logic on the cluster to prepare the automation. In our case, we install ArgoCD, some credentials, some secrets. Afterwards, we install the first ArgoCD application set, which maintain the entire cluster with all the capabilities. So for the demo, I've already provisioned a cluster and prepared some pre-steps. All the remaining steps we'll do them in the demo itself. Good. Means we have currently two clusters, Amsterdam and Berlin. Both have already ArgoCD installed. Amsterdam is already bound to the Aurora release. Berlin is totally fresh, only ArgoCD installed. And our objective is to create a new platform release named Blade and release Blade on Amsterdam and Berlin. Good. Okay, so we see here the repository. Looks hopefully fine. At the last slide, we will also have a QR code for the Git repository. We see here 3 directories. Let's start at the bottom. The capabilities, as mentioned, are some kind of capabilities that we want on the cluster. We have here a short list. In reality, we have the list is much bigger. But here we have some capabilities, for example, to install seal secrets, the patch operator, pipelines, also some external secret stuff and so on, and also in custom application. It's up to you how you organize the capabilities and so on. If we look, for example, at the pipeline, as mentioned, we are using customized. So we are, for example, the pipeline is like the Tekton implementation and the Tekton stuff. We install the namespace, we install an operator group, and also the subscription. We see here the subscription that we have a placeholder for the channel, for the version. So we use plain the overlay to define a version, for example, 1.8 or 1.9. And if we look at the customize for the overlay for 1.8, we see that we're making a replacement to set explicitly the pipeline. I think this is very straightforward. What we are also doing is that we are using the patch operator. So if you are not familiar with the patch operator, maybe make a note. It's very helpful, especially in the case that we have the requirement to modify existing resources in the cluster, especially, for example, here for the pipeline operator. The pipeline operator or the Tekton installs Tekton, and also one of the kinds is a Tekton config, defining all the different kinds of parameters. And our objective here is to modify some of the parameters, and we have not really a chance to modify this in the subscription of the operator. Here we can use then the patch operator to define some criteria for a specific object, here in this case, the kind Tekton with the name config, and how to patch then the object. This is then very easy to modify existing or generated resources in a Kubernetes cluster when we not have the chance to do this directly with Kustomize. Good. We see here also, for example, for external secrets operator, two different kind of capabilities. This means also that's really a result that we have two ArgoCD applications. We split them. So the general flow is we install the operator, then we have to wait until the operator is done and green, and then we can instantiate or modify and configure the external secrets operator. To avoid the wait loop and so on, we separate them into two different kind of ArgoCD applications. One is always for the setup, and the other one is for the instantiation. And this is the case, and it's very helpful in most cases when we have some kind of installation with operators. Good. And we have the custom map is very straightforward, only a simple deployment, printing out custom variable or an environment variable, custom env, with a default value from the config map. We will see later how to modify this too, or how to override this. Okay, so this is a set of how to structure, for example, capabilities that we can use on different kinds of clusters. As you can see, we don't have any relationship to the cluster itself or to any kind of a clusters. In the configuration, we have two subdirectories. Let's start with the version itself. We see here some possible versions, Aurora and Blade are for today relevant. If we look at the version, we see a very simple, well, a little bit simple, a YAML file defining some information. Let's say the first one is the revision, means the Git revision, where the information regarding the release, here in this case, release Aurora, is bound or tagged, and also a list of capabilities. Here also, we have categorization in mandatory capabilities, which should be always available on the Kubernetes cluster, and also, let's say, optional one. Each structure of a capability is very straightforward. We have the possibility to define a name, also if enabled or not, and also the information where to find the manifest files to define the capability itself. In our case, it's in the same repository, so you see always 0 capabilities. We see at this one for Aurora that we have 3 active capabilities enabled. The external secrets operator is false, so this is also possible to define already any capabilities but disable them. Good. And if we look at Blade, for example, we see the differences. In Blade, we have already implemented or added a new capability, the pipeline one, and also in a custom application. Good. And this shows maybe one of the advantages of the concept. It is pure, straightforward YAML files, and you can very easily compare the versions to see what kind of differences, how to test or how to verify this. Good. This is other version information. Also, only some information how to define a cluster, but not really a relation to a cluster itself. Now, in the cluster directory, we have some clusters defined. In this case, also only the first two are relevant, Amsterdam and Berlin. In Amsterdam, we have some information. Let's say the two relevant parts are the platform version. As mentioned, we have in the cluster YAML file the reference to the platform version using the name. This is like a soft link, let's say. In this case, Aurora is the same name as the directory. And in the version Aurora, we have then the revision defined, bounded to a Git tag. So he means we know, okay, the Amsterdam cluster use the Aurora platform version, and we have here also the possibility to override, as mentioned, some of the capabilities. Even both are false, let me say. Yes. Means also we have the chance to say, okay, for Amsterdam, for example, even in the normal version, the capability is enabled. We can say no, for Amsterdam, we want really disable of the capability. Good. So these are the main concepts or the main idea. Regarding Bootstrap, usually we are provisioning the clusters with some automation, Terraform or something like that, and we also trigger the bootstrap of the ArgoCD logic from Terraform, for example. But now here for the demo, as mentioned, we have very simple subscription for ArgoCD. We can skip this. Then we have, let's say, the bootstrap application set to enroll or to define to enroll to roll out the application for applying the capabilities on the cluster. The tricky part here is we have a generator, the matrix one, because the one and only entry point that we have is the cluster name. In this case, Amsterdam or Berlin, for example. Then what we need is, or what we have to do is that from the cluster name, we retrieve the cluster YAML file. In the cluster YAML file, we have the name of the platform version, which is only like a symbolic link. And in the version, we have then the information regarding the release. And then we can start and say, okay, with the revision, here then in the resulting, in the generated ArgoCD application, we say from the revision, please use then the version YAML and the cluster YAML, merge them, and create your set with the target definition for the cluster. So this is the tricky part, but we try to say our entry point is only the cluster name, and then try to figure out what kind of versions and what kind of version YAMLs do you need. Good. Let's have a look at the cluster itself. We have, as mentioned, two clusters. This one is, so this is the ArgoCD on Amsterdam. We have release Aurora. We have already the cluster bounded to release Aurora, and some of the capabilities installed, like the patch operator sealed and the catalog source. On Berlin, this is Berlin, is still empty, only ArgoCD installed. Now the objective is to say, let's create or let's finalize the Blade release. We see that the revision is currently bound to the main branch. And let's say also that the Amsterdam cluster is our a development cluster where we can try and finalize our releases. Good. Do we have to change here something? I would say first of all, no. The idea is we have the cluster YAML file, bounded currently to Aurora. Let's switch this to the platform version, save and git push. Usually we will create also some pull requests and so on. Let's skip this for the demo. So as soon as we have the change in Git, ArgoCD usually needs 3 minutes. I will skip this and refresh immediately. And we see we changed to main. Then, okay, retrieving that information because we merged them, version and cluster YAML. In version, we have now more capabilities. We have, what is more? I can't remember which was more. Pipeline. The pipeline is new. And now we have also pipeline, and we see now it's not bound to the release overrides to the main. We can see if everything is fine. Let's take another modification and say now we want to enable also the custom app. Maybe the interesting part of the custom app is we're not only changing the attribute enable, we're also changing the path. As mentioned, we have the possibility to enhance an existing capability, and we are doing so this for the custom app. As we see, we are not referencing the 0.2 capabilities. We have here an extension, customize for the custom app. First of all, we reference back to the original capability, and then we modify with the merge the config map to say the value is not the default value, now it's its Amsterdam value. Let's do this also in this way. Let's refresh again. Now we see again a new capability, in this case a custom app. We will see also the app on the cluster itself. Let's see the logs, and the logs are Amsterdam value instead of the default value. So means it's a little bit easy or very easy to use existing capabilities, but also to enhance existing capabilities as long you use the convention with customize. But now let's say we have a stable version, means latest fine. Then let's finalize the release and create a tag. Push. Now we have a tag with a release blade, and we also modify the revision to bound explicitly the version, the platform version blade to the Git release. Otherwise, it's still on main, and we'll get some modifications here. And in the meantime, we're also, I would say, let's change this to the on Amsterdam. Now we have already, yep, everything's fine. Platform is still pointing out to blade. Let's jump back and see. Now the release changed from main to release blade, and this is fine. Means again we have now bound to another revision. We can now still start working on main again without the modification of the configuration of the Amsterdam cluster, for example. Good. Let's say this is a stable version, and we need the same one on the Berlin cluster. The approach is similar. We only have to apply the bootstrap to get the capabilities, to get the ArgoCD running, the first ArgoCD application set running, and maintaining all the capabilities. I have here already this one. The structure is still the same. Now only the difference that is that we have now here Berlin, so pointing to the Berlin cluster. So I have the connection to Berlin, and let's apply this. Role binding is not new. Good. So, and then we see the bootstrap. We have installed the overall bootstrap. Then it's collecting all the information, version again, version YAML, customer YAML, merging stuff. We see it's bounded to the release blade, and then trying to get all the capabilities and install the capabilities on the cluster. And after some minutes, hopefully, eventually, everything is fine and green. Good. These are the main points. Let's jump back to the presentation. Good. So for the summary, we try to use GitOps to configure all the components, all the capabilities. You saw some helpful information, like we are using, for example, the patch operator to modify existing generated resources in the cluster to avoid that we have in the capabilities any cluster-specific configurations. We also try to decouple the setup and the instantiation of the resources. We try to version everything. Yes, we don't saw that we have some pull requests. It's very important that the main branch is protected and that you're using pull requests and so on. Otherwise, you can break everything. Usually, we also not try to roll back. Only fast forward is our approach. And these are the main points. And as interested, you have the QR code for the GitHub repository. Thanks for the time.
That was a wonderful talk, and I know it's always nerve-wracking to do a demo, so congratulations on that. We did receive a couple of questions on Slido. So the first one is, can you also model conflicts or dependencies between capabilities?
It's probably possible that you get still some conflicts if you define some capabilities in the lists, which have some conflicts in the version and so on. The human have to solve such kind of conflicts. So it's not from the automation here. Yeah.
The second question is, how would you manage clusters shared by multiple landscapes?
I'm not sure what landscape means, like a hypervisor or
different test scenarios. I don't want to read the whole thing.
Well, I would say for us, every cluster it's a production cluster. So you can say, for example, Amsterdam is a dev cluster and Berlin is CIT or something like that. So we don't see a difference between the stage. Each cluster it's closed as one instance.
Okay, the next one says, why do you use one Argo instance per cluster?
So in reality, we are not using one ArgoCD. This is only for the demo. In reality, we have one open. So the ArgoCD instance in the OpenShift GitOps, it's a master or it's a parent one, and then we create different kind of ArgoCD instances for different domains, and then we are scaling all the capabilities because we have also the same concept we are using on different kind of domains and teams, and the teams will receive their own ArgoCD instance.
That's all the questions we received on Slido. Are there any final burning questions from the audience? All right, let's have one more round of applause for Hafid for his wonderful presentation.
Thanks.